Okay, so in yesterday's lecture, we have talked about histogram equalization. Let us revise it in brief. So, as studied, histogram of low contrast image is usually concentrated in certain region. As shown here, this is a low contrast image, and histogram is narrow. And for this particular image, it is centered toward the middle of the grayscale. And when the image has good contrast, its histogram is distributed approximately equally over the entire available dynamic range. Okay, so if we have a low contrast image, we can modify it to good contrast image by processing its histogram. Okay, we can try to equalize the histogram in order to get an image with better contrast. Okay, so for this mathematical equation is S is equal to TR, where this TR is given by integral 0 to R PR omega d omega. So basically it is a cumulative distribution function. We apply this cumulative distribution function on original probability density function, or we apply it on probability density function of the original image, which is PRR. Okay, so we determine cumulative distribution function of the given image to determine new image which has better contrast than the original image. Now, what is discrete equivalent of cumulative distribution function? We can obtain it by summation operation, summation PRRJ, where J varies from 0 to K. This gives us modified histogram. Okay. So this is effect of histogram equalization. Say if we have a dark image where histogram is concentrated in lower 1/3 part of the image, when we apply histogram equalization, we get an image which has very good contrast. And if you look at the histogram of this equalized image, it is spread over the entire available range. Same is true for the second case. This is bright image. After histogram equalization, histogram is distributed over entire available range, and we are getting an image with very good contrast. Okay. Now in today's lecture, we are going to study this histogram equalization process step by step by using a simple numerical. Okay. So I request all of you to note down this image. Okay. So that we can perform all next steps. Okay. So this is a 4x4 image as mentioned here. Size of the image is 4x4. Total number of pixels is 60. Okay. And it is mentioned in the problem statement that the grayscale range for the given image is between 0 to 9. So total there are 10 gray shades ranging from 0 to 9. Total 10 gray shades are there, or gray values are there. And your input image is as shown here. Okay. So first row is 2, 3, 3, 2, and so on. So note down this 4x4 image. Now we want to apply histogram equalization on this image, means we have to follow these steps as mentioned here. First step is to identify the gray levels. Second step is to determine histogram, means to count the number of pixels belonging to each gray shade. Now, in the given example, there are 10 gray shades. So we have to determine how many pixels are there belonging to each of these gray shades, ranging from 0 to 9. Once we determine the histogram, next step is to perform cumulative addition, because we have to determine CDF, cumulative distribution function of the original histogram. After determining cumulative addition, we can normalize the CDF. Okay, so next step is normalization. And after normalization, we can multiply each normalized number by maximum gray value in the given example. Okay, so let us see how we can do it. So first step is very simple, that is gray levels. Now as given in the problem statement, there are 10 gray shades 0 to 9. So determine now number of pixels belonging to each gray value. Okay, now start with gray value 0. How many pixels are there belonging to gray value 0 in the given image? Please type your answer. For gray value 0, how many pixels are there in the given image? Yes, Sakshi, your answer is correct. For there are no pixels belonging to gray level 0. Same is true for gray level 1. Even for gray level 1, there are no pixels. Now tell me how many pixels are there belonging to gray level 2. So for gray level 2, there are, yes, Sharon, your answer is correct. There are total 6 pixels belonging to gray level 2. 1, 2, 3, 4, 5. Sorry, there are total 1, 2, 3, 4, 5, 6. I forgot this one. So total there are 6 pixels belonging to gray level 2. So all of you have answered correctly. Soumya, Pranav, Sharan, Sakshi, your answers are correct. Now similarly, determine number of pixels belonging to gray level 3, 4, 5, 6 up to 9. And please type your answers one by one, starting from 2 to last pixel value seen in this image is 5. For all the gray shades above 5, again count of pixels is 0 because there are no pixels with values ranging from 6 to 9. Okay, so I'm getting correct answers for pixel value 3. There are for value 3, there are 1, 2, 3, 4, 5, total 5 pixels. For 4, there are 1, 2, 3, 4 pixels. And for 5, there is 1 pixel. Very good. All of you have answered me correctly. So this is histogram of the given image. So on x-axis, we have all gray values as given in the problem. There are 10 gray values. So your x-axis ranges from 0 to 9 and y-axis gives you number of pixels belonging to each gray value. Okay. So for 2, there are 6 pixels. For 3, there are 5 pixels. For gray level 4, there are 4 pixels. For 5, there is only 1 pixel. And for rest all gray shades, there are no pixels. Hence, there is no peak appearing for other gray values 0, 1, 6, 7, 8, and 9. Okay. So this is histogram of the given image. Now, if you look at the histogram, total dynamic range available is 0 to 9. And the histogram of the given image is concentrated between 2 to 5. Now we can apply histogram equalization on this image to spread this histogram over the available dynamic range. Okay, so we have finished first step, that is determining the number of pixels belonging to each gray level, right? We have finished this part. Now let us go to next step. Now what is next step? Determining cumulative addition. So let us start with this first place. So first we take this is very starting pixel. So cumulative addition is same as very first count. So this first count is 0. So we will get a 0 here. Now for next step, add this number with current number of pixels. Okay, so 0 plus 0, add these two to get new addition, which is 0. Now, how many pixels are there belonging to next gray shade, which is 2? There are 6 pixels. Add this value to previous count. Add these two. So 0 plus 6 gives you 6. Okay, so this is next cumulative addition. Now perform 6 plus 5 to get next cumulative number, which is 11. Very good. Okay, and continue this process till last gray value, that is 9. So complete next values and type your answers in the chat box. Okay, Pranav, your answers are correct. So next is 11 plus 4. 11 plus 4 gives you 15. Then 15 plus 1 gives you 16. And rest all 16 plus 0, 16. So you for rest all gray values, you will get cumulative addition as 16. Very good, Sakshi. Okay. So whether this cumulative addition step is clear to all of you? If yes, we can proceed to next step. Okay, so after cumulative addition, you will get these numbers. So we have completed this step, summation nj, j runs from 0 to k. Now next step is to normalize this cumulative addition. So in this case, normalization means dividing all these numbers by total number of pixels. Okay, so our image size is 4 by 4. So total there are 16 pixels. So in the next step, divide each of these numbers by 16. So 0 by 16, 0 by 16, 6 by 16, and so on. So after this step, you will get these values, right? So last few columns are 1, 16 by 16 from 5 to 9. So this is normalization step. And after this step, we have to multiply these numbers by maximum gray value in the given image. Okay. So in the given problem statement, maximum gray value is 9. So next step is to multiply this S by 9 so that you can get all new gray values in the range 0 to 9, right? So last step, purpose of last step is to convert your gray shades to original gray shade, that is 0 to 9. So multiply all these numbers by 9 and tell me your answer for the final step. Okay, please type your answer in the chat box. So 0 into 9, first two values are of course 0. Next is 6 by 16 into 9. Then at third column, you will get 11 by 16 into 9. Okay, your first answer is correct, Pranav. Okay, and for from 5 to 9, 16 by 16 is 1. 1 multiplied by 9, you will get here 9. Okay. So these are results of after the last step. So when you multiply this 6 by 16 by 9, you get 3.3. Now, whenever we are using digital images, we need to round these values to the integer range. Okay. So round it to closest integer. So 3.3 is replaced by 3. 11 by 16, that is 6.1. It is uh, rounded to integer 6. 15 by 16, that is 8.4. It is rounded to 8. Okay. So these are your new gray values for original gray values. Okay. So in the new image, what we are going to do is, in order to determine new image, we are going to replace original gray value of 2 by new gray value 3. So here basically after this applying CDF and normalization, after completing all these steps, what we are getting is we are getting mapping between original gray value R and new gray value S. Okay. So we are going to replace value 2 by value 3. We are going to replace original gray value 3 by new gray value 6. Similarly, 4 will be replaced by 8. 5 will be replaced by 9, and 6 to 9, these values will be replaced by 9. Okay. 0 is replaced by 0. 1, original gray value 1 is replaced by 0. Okay. So after completion of all these steps, we get relation between original gray value and new gray value. So from the original image, all the pixels having value 2, now we have to replace them by value 3 and so on as per this table. Okay. So this is your resultant image. Okay. So this was your original image. Now from this original image, replace all pixel values with value 2. Now replace them by value 3 as shown here. Okay. So from your image, replace 2 by 3. Then as per this table, replace 3 by 6, 4, replace 4 by 8 and so on. So after this replacement, you are getting this image as new image. Okay. So all the values 2 are replaced by 3. Value 3 from original image is replaced by 6. Value 4 from original image is replaced by 8. And 5 is replaced by 9. So you get this new image, and we can call this image as histogram equalized image. Why we call it as histogram equalized image? Because if you look at the new histogram, it is approximately equal over entire available range. And as compared to original histogram, it is spread over greater range. Are you getting these points? Now, this is your equalized histogram. Now just compare this equalized histogram with your original histogram. This is original histogram. So original histogram was concentrated between 2 to 5. And now if you look at equalized histogram, as compared to original histogram, it is spread over greater range. Now this histogram is between 3 to 9. Okay. So it is spread over greater range and it is approximately equal. Okay. It is not ideal uniform distribution, but we can say it is approximately equal to uniform distribution. Okay, so this is your process of applying histogram equalization on the given image. So just revise these steps. First step is to identify gray values. Then second step is determine number of pixels belonging to each gray value. Third step is to perform cumulative addition. Next step, fourth step is to normalize these numbers by dividing each number by total number of pixels. And last step is to multiply these numbers by maximum gray value in the given image. For this example, it is given as 9. That's why we are multiplying these numbers by 9. Okay, so after completing these steps, we get mapping or relation between original gray shades R and modified gray shades S. Okay, so these are the steps to be followed for performing histogram equalization. Hope all these steps are clear to you. Now let us solve one more example to understand these steps. Okay. Okay, so before going to next example, just understand what is ultimate effect of histogram equalization. So as indicated in these four pictures, these are your original images. First image is dark image, second image is bright image, third image is uh, low contrast image where histogram is concentrated in mid portion of the total dynamic range. Okay, so these three images are having low contrast, and after applying histogram equalization, ultimate result is we are getting an image with very good contrast. Okay, so all these three results are showing you his improvement in the contrast. Okay, so we are getting an image with very good contrast. Now this fourth image, this is originally an image having good contrast. So though you apply histogram equalization, its contrast is same as your original image, because original image itself has good contrast. So after applying histogram equalization, we are again getting an image with good contrast. Now, if you compare all these four histograms, similarity in these four histograms is all these histograms are spread over entire dynamic range, and they are approximately equal. Okay, they are not exactly identical because this new histogram depends on what are the original contents in the given image. So these four histograms are not exactly identical, but they are more or less similar, and mainly they are approximately uniform in nature, and that's why these resultant images have very good contrast. Okay, now let us solve one more example to understand this histogram equalization process. So please note down this 4 by 4 image. Again, we are considering 4 by 4 image, but the pixel values are different. Okay, and here now in this example, it is given that available gray dynamic range is from 0 to 7. So as compared to previous example, there is only one change, that is your dynamic range is between 0 to 7. So for the histogram, your x-axis will have gray values from 0, 1, 2 up to 7. And image contents are of course different. So please note down this 4 by 4 image and perform all these steps. Apply all these steps and write your answers step by step in the chat box. Okay, so just write numbers separated by space for all the gray shades from 0 to 7. So as answer, you have to write 8 numbers. First step is to identify gray levels. So total there are 8 gray levels, 0, 1, 2 up to 7. Then determine the histogram. So determine number of pixels belonging to each gray shade. How many pixels are there belonging to gray shade 0 in the given image? There are 1, 2, 3, 4, 5 pixels. Very good. You are giving me correct answers. Now similarly, determine number of pixels belonging to all gray shades and write it in the chat box. For gray value 1, how many pixels are there? Yes, Mehak, Soumya, your answers are correct. There are 4 pixels belonging to gray value 1, 1, 2, 3, 4. For 2, there are 2 pixels. Very good, Pradnesh, Mehak, Soumya. Then belonging to gray value 3, there are 1, 2, 3, 4, and 5 pixels. Yes, Keshav, your answer is correct. So this is first step. After first step, we are getting these results. Okay, so for pixel, for value 4 to 7, there are no pixels, so these values are 0. Now perform next step, that is cumulative addition. Start with very first number. Next step is cumulative addition. So just copy the number as it is, which is 5. Then add this previous addition to current count, that is 4. Add these two numbers, 5 plus 4, you will get 9. Then 9 plus 2, you will get here 11. 11 plus 5, you will get 16. Then 16 plus 0, you will get here 16. And rest all numbers are 16. Okay, you will get here 16, 16, 16, because these counts are 0. Okay, so this is cumulative addition. Now after cumulative addition, next step is to normalize these numbers by dividing it by total number of pixels. So you have to divide each number by 16 to get this row, results from this row. Okay, and then multiply these normalized numbers by 7. Now in the given example, maximum gray value is 7. So we have to multiply each number from this last but one row by 7. So here you will get 5 divided by 16, and it is multiplied by 7, and then round it to the next integer. So complete all these steps and tell me your final row. What are the results in the final row? Okay, Pranav, good. What about others? Please complete the last row by following these steps. Yes, so I'm getting correct answers from few of the students. So I'm going to next slide. Okay, so okay. So this is your original image. This is original histogram. And if you look at the original histogram, it means this is a dark image because all the gray values are concentrated between 0 to 3, right? So this represents a dark image, which is of course a low contrast image because the range is narrow. So this is your first step, that is determining the histogram. Then cumulative addition, you're getting these numbers. Then next step, that is normalizing the cumulative addition. Okay, as shown here, you're getting the answers. And last step is converting your normalized CDF to original gray range, that is 0 to 7. And so we can achieve it simply by multiplying by maximum gray value, which is 7. So multiply these numbers by 7 and you will get this as your result. Okay, so these are the new gray values. Okay, so this gives us mapping between original gray value and new gray value. So according to this table, we have to replace value 0 from original image by 2, then replace value 1 by 4, replace value 2 by 5, and replace all original values from 3 to 7, replace all of them by 7. Okay, hope these steps are clear to you. So by by using these new values, we can get the new image, that is histogram equalized image. So in this image, replace all zeros by value 2, replace all ones by 4, replace 1 by 4, and replace 2 by 5. So replace these two pixels by 5 and replace pixels with value 3 by 7 to get the equalized image. And then you can plot the histogram for the equalized image. So this is your histogram equalized image, and this is equalized histogram. Okay, so if you compare this equalized histogram with original histogram as compared to original histogram, now your new histogram is spread over greater dynamic range and it is approximately uniform. If you look at the equalized histogram, we can say it has greater dynamic range, and hence we can say that contrast is improved for this histogram equalized image because it is occupying greater dynamic range. So are these steps clear to you? Please tell me. Type if you have any query, please type in the chat box.